In this video, we're going to learn how to solve trigonometric equations. However, before we even get into solving, we need to mention a few different things that they can present the question as that you have to take note of and how you're actually going to solve it. The first thing they might ask is they might ask you to find degree solutions, or they might ask you to find radian solutions. This isn't going to affect your process too much. Just at the end of the day, if you're going to give your answer as a degree or as a radian, they will go ahead and tell you in the problem and make sure you follow the instructions. The second thing they're going to bring up is they will say, I want the solutions for one full trip around the circle. If it's in degrees, that means they will say they want all the values between 0 degrees and 360 degrees. If it's a radian problem, they will say they want all the answers from 0 to 2 pi. But they will specify this in the question so that you know you only want the answers going around the circle a single time. Notice that if you went around the circle and got a solution, if you go around the circle a second time, you're going to get another solution, and a third time another solution. And so if you were to keep going any number of times, you actually can get infinitely many different solutions this way. And sometimes they'll want that. And if they want all the solutions, they will say, find all the solutions, either degrees or in radians. And obviously, you can't just write down infinitely many different answers on your paper. I will show you how you write down the answer to include all infinite possibilities. The third thing that you want to worry about is that they may want the exact answer for the angle, so exactly 30 degrees, exactly 2 pi over 3 radians, something like that. Or they might ask you to approximate the angles that you're looking for here. Instead of saying it's 30 degrees, it is 28.4 degrees, something like that. Now, mainly, they're going to ask you to approximate when the angle you are finding is not one of the special angles. It's not from the 30, 60, 90 right triangle, and it's not from the 45, 45, 90 right triangle. So if you're getting a weird value of sine, cosine, tangent, something like that, that does not fit on your unit circle, the special points, then you have to use your calculator and get an approximate answer, and they will tell you to approximate there. If they don't tell you to approximate, then they are expecting the exact answer for the angle. With all of that out of the way, again, when you see a problem, look for 3 things. Do you want degree, radian, one time around the circle, or all of them, or the exact or approximate answer? Once you have those in mind, then you can get down to actually solving the equation. Now, my first equation here is 2 sine x minus 1 equal to 0. Before I solve the trig one, let me just remind you, like an algebra equation, if it was just 2x minus 1 equals 0, then you would add 1 to both sides, then you would divide by 2 both sides, and you'd have a value of x is 1/2. So in an algebra class, when you're solving algebra equations, you perform operations like this in order to isolate the variable x, and we're going to do something very similar with trig equations. So for this trig equation, 2 sine x minus 1 equals 0, we start by adding 1 to both sides, just like the algebra equation. That would then be 2 sine x is equal to 1. We will then divide both sides by 2, just as we did before, and we have sine x is equal to 1/2. The difference is we're not actually trying to get x alone at this step. We're trying to get the trig function alone, so sine x is alone here. And then we're going to use the unit circle to figure out the values of x. So if I draw myself my unit circle here, sine x is 1/2. That means we're looking for a point on the unit circle whose y coordinate is 1/2. That's going to be a point right here and a point right here. And those are going to be the points with reference angles of 30 degrees. And so that's going to be x is 30 degrees, and the point in quadrant 2 is 150 degrees. So these are special angles in the unit circle. I can give the exact value here, and we have our answer to our first trig equation. For our second trig equation, this time we have a cosine involved, so we're going to try to isolate that. We'll go ahead and subtract 2 from both sides. We get 5 cosine x is negative 2. Divide by 5. We get cosine x is negative 0.4. And notice they do want radians this time, so we need radian answer, and only one time around the circle. The difference here, though, is that there is none of the special points where cosine gives you the answer negative 0.4. That's not from a 30, 60, 90 right triangle, and that is not from a 45, 45, 90 right triangle. Neither one of them will give it to you. However, we are going to have a point somewhere around here where the x-coordinate is negative 0.4. Don't know what the y is right now. And a point down here where the x-coordinate is negative 0.4. So we know that we're going to have an answer in quadrant 2 and an answer in quadrant 3. Don't know what they are because it's not a special angle. So what I'm going to go ahead and do is I'm going to use my inverse trig functions here. I'm going to do cosine inverse of 0.4. I almost wrote down negative 0.4 there. But instead I'm going to do cosine inverse of positive 0.4 in order to find the reference angle. I want to find the reference angle here. And if I put that in my calculator and round to the nearest tenth of a radian, that would be 1.2 radians. So I know that's going to be my reference angle for both of these points. Then I can go ahead and find the actual points. So in quadrant 2, you would go pi minus the reference angle. In quadrant 3, it's pi plus the reference angle. And using our calculator, we get an angle of 1.9 radians and an angle of 4.3 radians. So you can see it's a little bit trickier when we have to use a calculator to approximate rather than one of the special angles. But it's still best to find the reference angle and then shift it to whatever quadrant you need for the answer. Now for this third question, it's another approximation. This time it is degrees, and it's a tangent function, so we're going to go ahead and solve it the same way we've been doing. Add 4 to both sides. 3 tangent x is equal to 4. And we get tangent x is 4/3. Once again, this is not a special point on the unit circle. Those ones are like tangent is equal to 1, or tangent equals root 3, or 1 over root 3. Those are the ones that get special points here for tangent, not 4/3. However, we know that there will be a solution in quadrant 1, and there will be a solution in quadrant 3. Those are the places where tangent is positive. So I will go ahead and do my inverse tangent function here. This time I want to make sure my calculator is in degree mode, because they specify in this problem to use degrees. And if I put this in my calculator and I round it, I get 53.1 degrees. Now that is the reference angle, and that's also the reference angle in quadrant 3 here. Now because we're in quadrant 1, then the reference angle is just equal to the angle, 53.1, and the other answer is 180 plus 53.1. And if you add those together, 180 plus 53.1 is 233.1. Now I left a little space here because we did not deal with the fact that they asked us to find all possible degree solutions, not just the ones around the circle one time, They want you to be able to go around the circle any number of times and still find your answer. Now here's the way we're going to do that. If I go around the circle one whole time, that's 360 degrees. If I go around the circle twice, that's 360 and another 360, or 2 times 360. And so the idea is that no matter how many times I go around the circle, it's just 360 times some number. And so to get all the possible angles, we say add 360 times some number k. And this is how you're going to denote all possible solutions instead of just once around the circle. So it'd be 53.1 plus 360 degrees times k for any k, as well as 233.1 plus 360 times k as well for any integer k. So when you're asked to find all solutions, you're just going to add this term that says go around the circle any number of times, and that's how you're going to get all the possible solutions. Now this last problem is a find all radian solutions, and there is something a little bit more tricky. We'll notice that this one has both a sine and a cosine in it. It's not just a single trig function. So I can't just isolate one of them when I got two of them here. However, what we can use is other tools from algebra to help us solve this problem. And the tool that I'm going to use here is I see they both have a sine x. I'm going to go ahead and factor sine x out. And it'd be sine x times 1 plus 2 cosine x. And you can check, distribute that back in, and see if you get the previous step. You should. And now I have two things being multiplied, giving me 0. That means either the first thing is 0 or the second thing is 0. And then we handle each of them separately. The first one's just sine x equals 0. The second one, we do a couple steps. I'll skip the work here. We're going to get cosine x is negative 1/2. And so let's see what points satisfy either one of these. For sine x equal to 0, that's the y coordinate is 0. That's either 0 radians or pi radians. That's the two places that sine x gives me 0. And then the two places that cosine gives me a negative 1/2, that would be 2 pi over 3 and 4 pi over 3. So drawing the unit circle just for reference here. Sine is 0 at these 2 points. Cosine's negative 1/2 at these 2 points. And then since we want all possible solutions, and one trip around the circle is 2 pi, each one of these is going to be plus 2 pi k for some integer. And this then gives us all the possible infinitely many solutions to this equation. Okay, so this is an important video. We're going to have more videos on harder trig equations to solve, but you really want to get this step down first before you move on to the more complicated ones.